Okay, let's take a look at the first few problems from the Unit 3 review. There were some questions that you guys asked. And so let's look at these first, this idea of these true and false questions as we go through them. First, we're thinking about, again, a derivative. And again, a derivative describes the rate of change, right, of a function. So you think about a function and then you have values and they're either increasing, decreasing, staying the same. And we've learned that there's a lot of different types of functions, and we get some crazy looking ones in calculus, but this one here, that every function has a derivative. Now you have to go back to thinking about, well, what is a function, right? A function, going back to a definition, it's easier to think about it as in graph form, and so many of you guys use the absolute value. That is a function, the absolute value function. Right, and then we learned that a function is not differentiable at this point. So looking at these points here, that's an example many of you use, that at that cusp or that sharp point, right, that corner, a derivative doesn't exist. But you can see here as we think about it, and I highlight this here, this function is decreasing, so that's where we know the derivative is negative, right, at any of those points, and it's positive at any of those points. So many of you use the absolute value to describe that. There are other functions, of course, that are functions that don't have a derivative, right? So you have the answers already, but so something to think about, right? You have these other kind of piecewise functions that we may have, right? Where you have goes there, open, here, and then here, and you can see at 0 the function wouldn't have a derivative. These piecewise functions, again, you kind of have these unique looking functions. 2 was false also. Every continuous function has a continuous derivative, and so the absolute value function, again, for this one will satisfy that as a false, as a counterexample. And of course you can probably think of other ones. This one is not a continuous function over here, right? This is not continuous, so that wouldn't fit that, but the absolute value is, and there's other ones too, but that's a classic one, and that comes up a lot, the absolute value function. Every continuous function has a derivative, has a continuous derivative, and that again we saw that's not true because it's undefined there. And then every continuous function has a derivative. You'll see that the same thing, right? It's false because it doesn't have a derivative here. So you can keep that in mind there. I think number 4 is true. Yep. If a function is differentiable, if it is continuous, right? That's true because if a function, let's read this. If a function is differentiable, it is continuous, right? So it's an if-then statement. So if we know a function is completely differentiable, we know it's continuous because it wouldn't have these breaks. And remember, on our challenge problem, our concept problem, one of those questions was, when is a function not differentiable? So you want to go back to those ideas to think about that. So that's problems 1 through 4.